Okay, good day guys. I'm going to show you how to use FET circuits to model some series and parallel circuits, and for you guys to investigate how current and voltage behaves in a series and parallel circuit. So first things first, open up a web browser and just put in FET and search it. For me, I've got it here, fet.colorado.edu, and this brings you up to the website. Now, one of the beautiful things about FET is there are a whole range of simulations on here. The majority of them now are HTML5, so most of them work on multi-platform, on your iPads, on Android, or on anything, but also on through a web browser like this. So we go to physics, and then we go for electricity, magnets and circuits, and then we want circuit construction DC. It doesn't matter which one you go on, whether you go on the DC one or the virtual lab one for this, and in fact we'll go on virtual lab because that'll be handy for later on. Okay, so press play, don't need to worry about downloading in bed, and it will come up in your browser window like this. Okay, so first thing I would like you to do is to grab a battery and a bulb. There's our bulb. Okay, and what we're going to do then is you are going to take an ammeter, put it next to our bulb. This is going to be ammeter 1. We'll put another ammeter next to this bulb and another ammeter on this side of the bulb, and then we connect it all up with wires like so. And before I connect this up, this is then over to you, so you can now pause the video. I'd like you to record on your sheet or in your book, draw this circuit in circuit symbols. Here are the symbols. Obviously the ammeter symbols haven't been done, but we'll go to what they should be afterwards. And then what I'd like you to do is to record what each of these ammeter is saying. Okay, right, so pause video now. Okay, so hopefully you now come back and you've done it. So I'm going to do this, and I found that I got 0.9 amps everywhere. So all the way around these circuit we have got the same same current no matter where we are in the circuit. Okay, right, then we're going to break this thing. So we just left click on here, click the thing, we break it apart. Now what I'd like to do is to add a second bulb in, like so, and we'll place an ammeter in between them. Like so. There we are, and then we'll connect this up and see what we get. So again, pause the video here, do it yourself, record what you get. Okay, so hopefully you're back. I've now connected this up, and what you will notice is that the current is still the same everywhere, but the current now is half what we had before. So by adding a second bulb in the circuit, we've reduced the current, and if you notice, the two bulbs are now not as bright as what we had before. Okay, we'll leave this circuit like this. What about voltage then? So what I'd like you to do is you move these around like so, just drag and drop, is I'd like you to measure the voltage across each bulb. To do that, what you're going to do is place these two probes on either end, and you will get a value on here. What I'd like to do is to probe this bulb, and then probe this bulb, okay, and then finally probe the battery, place one either side of the battery. And what I'd like you to do is to notice what you get from them. Okay, right, pause video now for you to do that. Okay, excellent. Hopefully you've done your voltage, and you will have noticed that our battery has puts out 9 volts, our one bulb has 4.5, and our other bulb has 4.5. So two things in series share the voltage. Now these bulbs at the minute are identical, so let's make them unidentical. And you'll notice that even still, this one's 6.43 and this one is 2.57, and together they are still 9. So two components in series share the supply voltage such that, or however many components you have in series share the supply voltage. Okay, right then, we are going to restart. So that is series circuit. Now we're going to go into a parallel circuit. So start with one bulb, like so, and let's make it a little bit neater. So I'll have two wires coming out like this, wire coming down, wire coming down. Here's another bulb, wire coming down, wire coming down, and we connect up our bulbs, like so. Okay, so here is a parallel circuit. Parallel circuit's more than one loop, and you can see if you follow around one of the blue dots, one of the electrons, for it to go through both bulbs, it has to take two trips around. So here's a bulb going along, here's an electron going along, and through our bulb, and all the way down here. Yeah, going all the way up, and then to go through this bulb it has to take another trip, so they're in parallel, more than one loop. Okay, I'm going to do exactly the same. So you are going to place an ammeter here, an ammeter here, and an ammeter here, and see what you get. Pause the video now for you guys to do it. Okay, excellent. Hopefully you're back and you can see I've now added my ammeters in. Okay, and hopefully what we notice is that the current is splitting along each branch such that the current out of our battery is going to be the same as the current as is the sum of the currents going through each branch. So 1.8 amps out of our battery and 0.9 amps going through each cell. Okay, right, what about voltage? So do the same with voltage. Measure the voltage across each bulb and the battery like we did before, record what you see and write a conclusion saying what you've come up with. Pause the video now for you to do that. Okay, so we'll do each bulb. This bulb's got 9 volts, this bulb's got 9 volts, and the battery has 9 volts. So things in parallel, each one in parallel have the same voltage. Okay, so to sum up, let's rebuild our two circuits, and so we can see all of our conclusions together. Okay, so in terms of current then, in a series circuit the current is the same everywhere. Doesn't matter where it flows, the current is the same. And in a parallel circuit you can see that the current is splitting, and you can see that by these little electrons. Some go one way, some go the other way. And in this one, because these bulbs are the same, it's one each way. In terms of the voltage then, voltage in parallel, the same on each branch, the same as the supply. In series, the two components, the voltage splits. If they're the same component, then it will split equally. If they're not the same component, then they won't split, and then they'll split in a ratio that we'll discuss later on. Okay, thanks for watching this video. Hopefully that's helped.